Hello. This is BlueLive. It's a Bluetooth battery-powered controller that I built for use with Livestream Studio. I built this so that I could switch things without having to use the regular keyboard. This video is going to show you how to build it, and also there's a full tutorial step-by-step on Adafruit.com. This project took me a long time to actually engineer. To build it yourself is a lot shorter, but it took place over the course of about 5 months. So to celebrate, I baked a cake. Let's do this.
So it's important with any project to make sure that you test the circuit. In this one I just have a button hooked up to the LED to make sure that the MCP 23017 is working, because it's a little bit of a weird circuit, but it works. Also, don't use jumper cables to test connections with the Metro. Doesn't work, so solder your stuff in. I tried, it didn't work. Protoboard is honestly one of my favorite things that Adafruit sells. This is the sockets that are for the chips. It's really great because you can remove stuff and it keeps you from accidentally overheating chips. Just make sure you get the indentations right. I usually like to solder the outside edge of the chips. That way they won't sort of shift accidentally while you're doing it. Keeps it a lot easier to make it lined up at the end. Make sure that you leave enough room for the mounting holes. I inset these each by 1 on either side. That way I just had room for the screws at the end. And make sure you get the indentations right. The little dimples need to line up on the sockets as they do with the chips themselves. After that, I then wired in the ground leads. This is so that the chips are named. This is the default ground. You can use hookup wire for that. It doesn't really matter because this is not going to have to move. Here I am gluing in incorrectly using hot glue, trying to meet up the 3D printed pieces. Don't do this, doesn't work. It's a waste of time. This is me using cyanoacrylate crazy glue. The problem with this is that if you use a lot of it, it'll actually discolor the PLA. I didn't know this. I should have used E6000, but I didn't have any on hand. But it does work, it's just that it discolors the pieces. And this is me putting it a little bit on top. You don't need to do this. In fact, you should just use E6000. I didn't, so I'm just showing you the steps. This is me gluing in the top pieces together, the top halves, using the same method. Here you can see the frosting that's happening with the top pieces from the glue. I actually tried to color it in with a Sharpie and it just didn't match correctly with the color. It looked equally as bad. And once I had finished, I realized that I had committed to this, because, well, so instead I used Chem wipes along with a mix, a 50-50 mix of alcohol and acetone, and kind of tried to do a wipe down. And it actually worked perfectly. It basically almost did a wash of the Sharpie against the PLA, and afterwards it looked correct. Here you can see it drying, it's pretty cool. I was pretty stoked about it. This is a problem of curling I had with nearly all the pieces. It came up as a really big problem on the sides because they needed to match at the bottom, otherwise the whole piece itself starts to warp and you have trouble making the pieces line up. I tried to sand down the curling using some sandpaper taped to the cutting mat, and this did not work. So don't do this. What you should do is you should ensure that your print bed is fully level and print slightly thicker pieces. And I also had a problem that because there had been curling on the bottom and the top pieces as well, the walls that were originally measured didn't line up with each other. Here I am trying to glue the walls down to the base just so everything would line up, and that didn't work. I printed everything in pieces, that way if there was a problem I could reprint it, without generating a huge amount of scrap. Next I tried to print some stabilizer pieces in order to sort of hold the walls in tension. The thing I later discovered was just to print the walls thicker and with a giant raft, and that fixed the problem. You'll see later in the project whenever the walls go from black to white, and that's when I redid them. Here I am attempting to use the stabilizers with some crazy glue since the hot glue didn't work. And it won't stick and hold the piece. So I printed another one, stuck it underneath it like a shim in order to get that to stick to the sidewall and hold everything from really wobbling, and that did work. But it worked for something that I would later replace and make right in the end. A cool little trick with crazy glue, if you ever need to, is that with a little bit of baking soda, it acts as a kicker for the glue, so it basically dries instantly. This is just more showing you the process than it is saying you should do any of these things, except the kicker part. That's really helpful. I soldered up the enable pin and the ground pin to the Power Boost 1000C. I'm using this to run the Metro 328, so I also soldered in the USB port off camera. I then secured it to the little bumper that I made. I used screws on this one because if you're using the USB jack over and over again, I wanted to make sure it didn't pop out of the bumper. It's a lot easier if you tin the pins on the switch before you try soldering to them. I'm putting out a little bit of baking soda again in order to secure the bumper for the Power Boost to the bottom plate. Just put a little bit of cyanoacrylate on the bottom, but really you should be using E6000 as a reminder. Push it down, and honestly, that had already dried by the time. I recommend gluing things down with the boards attached, that way you can see how they lay out. The arcade button hack is really, really great. No way in Pedro Ruiz had such a good idea with this. You'll need a 3D printer in order to make it work, but it's really fun. Whenever soldering, make sure you have ventilation, because this is a demonstration of just how much smoke is generated from this solder when I was tinning these wires. Soldering to these PCBs can be a little bit tricky, so just take your time. Now originally I did this entire braid using hookup wire. This was a terrible, terrible idea. Make sure to use silicone wire. Do not use hookup wire. It won't work. To give you an idea of how difficult it is to feed the LEDs through with hookup wire, it took me 3.5 hours to feed this wire. That may seem crazy. It is crazy. Use silicone wire. This is like watching me make mistakes in slow motion. Right here I was actually showing how to resolder some of these wires in case you didn't cut enough length. But all this is going to be moot because hookup wire sticks. It will not work. You need the flexibility of silicone coated wire. And sticks. Terrible. So I ended up having to cut all of it out. 3.5 hours completely down the drain. Whenever doing the second round, I decided to use some blue tack. It makes it a lot easier to solder the wires to the PCBs, since they were already pre-tinned from the previous attempt. It really doesn't matter how much length of silicone wire you use. I mean, you don't want to use too much. Because it's so flexible, you can actually get it to fit pretty well. Just, go a little bit conservative. If the blue tack actually sticks due to the heat, it's pretty easy to get it off. And you can use tweezers. This was so much faster with the silicone wire. Took no time at all. Hooking up the buttons is pretty easy. I like to make a little hook with the wire and then secure it with pliers using a little bit of gentle pressure, and then just solder. You can tie all of the grounds together for all of the buttons. I use these yellow wires to hook back to the proto board for the MCPs. Here I'm putting resistors onto the ground pin for the LEDs for the push buttons. So because I had originally doubled these up, I was hoping to use less resistors and therefore less soldering. But whenever I wired it up to test it, I ran into a weird problem where the coloring was actually very different. I'm not doing anything to that shot, it's just different. I wanted to make a ground and power rail for those LEDs. So at first I took a proto board and then tried to snip it, and that didn't work. Then I decided that what I would do is I would score it and then just snap it off. This seemed like an easy idea, and then it took a half an hour to actually score enough. So even though this seemed like a good idea, it wasn't, and I don't recommend it whatsoever. I then tried to print a mount for it, but again, this was all moot. This is not a good idea. This is not the way you want to do it. Instead, you want to use Bakelite. Bakelite is awesome. It smells like formaldehyde, which is kind of gross, but it's really, really easy to work with. When cutting, make sure you leave enough room for a little bit of slop because it's pretty fragile when you cut and has a tendency to kind of flake, so leave yourself enough room. Here I just drilled holes for the screws for the mounts. Printed out some standoffs and was ready to go. I then soldered in the power and the ground rails. Then my favorite part of the whole project was actually flooding these to bridge them. This is just really fun. If you do a lot of precise soldering and then have to do this, it's just really satisfying to just throw solder at something. And now the LEDs look balanced. I then applied a little bit of crazy glue because I'd used it already, may as well keep going with it. And then just apply it to the top panel of the case. I then started work on finishing the circuit. Make sure to use a debounce capacitor. This keeps the LEDs from flickering and just balances everything out. You'll also want to use a resistor somewhere between 300 and 500 ohms for the data line that drives the NeoPixels. I found some space next to the Bluefruit module. You'll have to pardon my hands being so large in the shot. I'm still kind of working out how to film this correctly. Now these are the wires for the actual buttons. I then hooked up the SDA and LCL lines to the Metro. I use really thin solder whenever I solder, unless I'm doing something like tinning or flooding like I was to make those bridges. I find that thin solder is really helpful at going slowly and making everything precise. Also, the proto board is great that if you do make mistakes, it's really easy to try again. Make sure whenever putting the chips back in to line up the dimples. It's helpful to bend the pins in a little bit when putting the chips in. For the battery, I like to apply a little bit of Kapton tape before putting any kind of Velcro on the back. That way the Velcro is sticking to the tape rather than the outside foil of the battery. Make sure never to solder to this with the battery attached. I only attached this whenever the soldering was done. And if I needed to do any touch-up work, I removed the battery. It's very dangerous to solder to anything with the battery attached. Don't do it. Really don't do it. I then put in the proto boards. Put in the Metro. Hooked up the USB cable. And tried to put the top portion together and discovered that I had not made the walls tall enough. So I then printed new walls that were thicker and taller and lined up correctly. I made slight temporary adjustments to the design to take into account the curling that had happened. The files that are posted on Thingiverse are the accurate dimension. These were made a little bit shorter in order to fit. I then used some stabilizers with some hot glue in order to attach them to the bottom plate. These worked great. And I designed 3 different kinds to fit whatever design needs you may have with your project. Now that everything was wired up, it was ready to close it. I then attached the top portion to the walls. And on the bottom part, you can actually use the rubber bumpers that come with the Metro for the rubber bumpers on the bottom of your project. It's really great. I had a little bit of a problem getting the top part to line up, so I made a facade that I could then put into place with some glue. This was a lot faster than reprinting the whole top shell and resoldering everything. Because it stuck out just a tad, I then used some emery boards in order to file it flush. Now you'll notice on this that there's no animations and also that the buttons are reversed. I didn't notice that until much later in the project. I decided to label it, so for that I used some charting tape and a white paint pen. Charting tape doesn't have the strongest adhesive, but it will stick to PLA if you put some pressure down. I tried cutting it to length on the mat, but I had a lot of problems just getting it to cut at all without tearing. I ended up just sort of ripping it clean and then putting it into place by hand. I then dabbed a little bit of glue on the ends to make sure they wouldn't stick out. Then you can start labeling. I added a white color change in order to give you some feedback on pushing a button. This entire project was designed to work with Livestream Studio. You can use a regular keyboard, but I wanted one that was more customized for me. If you get a dedicated piece of hardware from Livestream, it ships with Windows 7. I tried to get it to work with the Bluetooth 4.0 dongle that comes from Adafruit. Even though it would download the drivers from the internet correctly, it wouldn't find the Bluefruit chip. So instead I found an ASIO dongle on Amazon for Bluetooth 2.1 and it worked perfectly. This was a huge relief. You can't hear me screaming with excitement right here. Because the bezels are clear on the arcade buttons, you can see that it's both on and charging from the top. Of course, you'd be able to tell it's on anyway because it's all lit up. And that's it, we're done. If you'd like to see the full tutorial, check out adafruit.com. Thank you for watching.
Beep, beep.